multiplication and division. Why? Oh, first thing I should ask you, why do they call them rational functions? What were rational numbers?
Non-terminating and non-repeating.
Okay, I just got both answers. Rational numbers were either non-terminating, or actually terminating and repeating decimals. Irrationals are non-terminating, or they are numbers that can be written as fractions. So if they say you see rational function, means these are going to be fractions with variables. That's what we're doing, fractions with variables. Okay, so first we're going to multiply and divide, and I need to ask this question back to the basics. If I said multiply 14/15 times 24/35, how do you do that? You could multiply them just as they are, but that will give you really big numbers. What are you allowed to do to make it equal? You can reduce. What can you cancel with what, or where can you cancel? Any numerator with any denominator. You can cross, go diagonal, or you can reduce within the same fraction, because we reduce fractions all the time. So any top can reduce with any bottom if you're multiplying. So what can I reduce here? Okay, I got two of them. I heard 7s and I heard 3s. I could take 7 out of 14, which would leave me
2
and 5, and I could then take 3s out of 15 and 24. Then, okay, the bigger question, once you have reduced it, how do you multiply them?
16, 25.
Yeah, straight across. Numerators multiply the denominator. So we would indeed get 16 over 25. No big deal, right? Okay. So now I'm going to put variables in them. Okay, so it's going to bring back something else we've learned this year. You're going to be very excited to see return.
Conjugates.
Oh, there's a little conjugate. Yes, conjugates are coming. Well, you conjugate verbs. That's a different type use of it, but. Okay, now, am I allowed to, like, cancel the 4 with the 16?
No.
No, why? If you have terms that are pluses and minuses, you have to cancel whole quantities. You can't do individual terms if you are separating with pluses and minuses. So we have to get these broken down into things that are multiplied before we can do our cross-canceling, which means we get to do our favorite activity. You got to factor all those. Okay. Which, actually, I want to do a quick review of factoring.
We did this before.
Yes, we did this before, and I told you it would be coming back. It's back. Where you, by the time you're done with this section, you are going to be good factors. How did you do perfect squares that were subtracted? They're easy.
I like plus, minus.
Plus, minus. A, B, A, B. One with a plus, they're conjugates. One with plus, one with a minus. How did you factor squares that were added? Will it work when I do A plus B and A plus B? Will the middles cancel? No. In fact, you can't ever get the middles to cancel with the plus sign. This is not factorable. If you get something squared plus something squared, you can't change it. You're stuck with it. You just leave it. It will not factor. Now, the one I'm worried about, because this is the first year you've seen it, how's about the one with factoring cubes? It's 2 terms times 3 terms. Okay, the 2 terms were easy. You took what you had here to start with, and you just uncubed it. So it would become A minus B. It's the trinomial that you have to remember the pattern, and there is a pattern.
A squared.
Yes, you take whatever you wrote here in the first spot and you square it. Okay. How do you know plus or minus? If this is a minus, it's a plus. You do opposite. And then you multiply the 2 things you wrote there in the binomial. You take A times B. And then the third term? Okay, you are going to square the last thing you wrote here, because you squared the first one, so then you're going to square the last one. What happens to the signs anytime you square a number? It's always positive, so that last one will always be positive. You're squaring it. So you'll get plus b squared. Were you allowed to do it with a cubed plus b cubed? Yes. Exact same rule, change two signs. The binomial becomes a plus b, so the middle term here becomes minus ab. The last one's still a plus because you're squaring it. Okay. So that's two terms, squares and cubes. Y'all can factor three terms in your sleep. How many trinomials have you now factored down and solved? I don't notice anybody have much trouble factoring trinomials anymore. Okay. The one other thing we factored was four terms?
No, it's hard.
No, it wasn't. Three terms, or the cubes is the one people have trouble with. Four terms, you actually get in Algebra 1, usually we don't have trouble with. Grouping, yes. Yeah. Yeah. Four terms is grouping. I just need to remind you that you know how to do it. So let's do a four-term one real quick. What do you group? Most time it works if you do first two and last two. And for what we're going to do, first two and last two will definitely be working. So you group the first two and you go, what do I do with the first two? You ask yourself, what's the common factor I can pull out? And so Michaela's right, I would pull out x squared, which would leave me? Okay. Then the second two, what can I pull out? And you need to ask yourself, am I pulling out a plus 2 or a minus 2? The sign matters. You need a sign in between these. So that would be a plus 2, which will leave me with what? Okay, am I done? My problem is I always have people want to stop right here. Yeah. When you get done, you have to have two binomials multiplied. Now the question is, why does this thing become two binomials that are multiplied? There's a plus in the middle.
You take the x squared plus 2 and then the last two terms are the same. Because since the last two are the same,
these two are a common factor. You got the same factor in both groups. What do you do with common factors? You pull them out front. If I pull x minus 3 out front, what will be left? X squared plus 2. It works because you're factoring common factors. You're pulling out a common factor. That's why it's legal. So when you get done, you should have two binomials. You're not done until you got two binomials. That's important. Okay, so now that we've reviewed that, let us work this lovely problem. So you're looking at the first one going, x squared, two terms. It's a minus.
4 and 4.
Yep. With what signs in it?
Plus 4.
Yep, this is the one that's conjugates, plus 4, minus 4. This is the one you like, it's easy. Okay. Bottom one. That's a cube, but is 64 a cube? Yes, it is. Yes, it is 4 cubed. Yeah. So it is perfect cubes. So therefore I can factor it 2 terms and 3 terms. I'm going to need more space. So how do I figure out what my 2 terms are? Uncube them. So it'll be x plus 4. Okay, everything hinges off what you wrote just right there.
Whoa.
So I'd square the first one, change the sign, multiply what you wrote right there. 4x, and then square the last number, plus 16. Okay, so do I have to try to break that down farther? Normally a trinomial would, but this trinomial that comes from factoring cubes will not break. You cannot find factors that will make that 4 in the middle. You cannot get it to work. So if you've factored cubes, this will not factor farther. You're stuck with that. That's good news. All right. This one's weird. Top of this next fraction.
take out an x.
Take out an x. Yeah, look for those common factors. And once you take out that x, do you notice anything you've seen before? Yeah, isn't it the same thing as over here? So we're going to be able to cancel here in a second. Okay. The last one, 4 minus x. I mean, it doesn't look like there's anything, but does it bug you?
Yeah, it really does like your
Yeah.
X minus 4.
Because to cancel, we need to be x minus 4, not 4 minus x. Yes. You're going to do that a lot in this chapter. You're going to need it to reverse. You got your signs backwards. So you factor out a negative. You go, okay, if I pull a negative out front, the x becomes positive now. The 4 changes to a negative. It causes them to switch. You can't do that. It doesn't work. Yes, you'll just leave the negative there. Yep. Now, this is the part, I remember when I first learned to do these kind of problems back in Algebra 1, and I got to cancel all this stuff. I just thought that was the coolest thing, because I took this big mess and canceled it all out, and it was like,
You didn't have an Xbox then.
nope, you're right. But you know what, Cody, if I had had an Xbox, I'd have still done my homework first. Well, therein is the problem, isn't it?
Yeah, sorry, though.
Atari was out. My husband had Atari. I didn't. I admit I could have gotten addicted. When I retire, I'm going to play video games. I'm going to go to college and I'm going to play video games. And I'm going to read books.
Wait, what if they're even better math video games?
You're gonna invent one of those. Create like a calculus
Hey, we're still recording.
That's right, we are. Tell me what else I can cancel. The x plus 4, because you can do top to bottom direct. Those can go. And then I can do the great big huge trinomial. So what's left? Technically, it's an x over a negative 1, which the better way to write that would be a negative x, yes. And so my answer on that one you don't usually get them that small, but that's really simplified. We got it down to a negative x. Okay, one thing I want to point out about negative signs. On fractions, does it matter where you put the negative?
No. Yeah.
Is there a difference between...
It's right there.
It is, but I want it on the board since I'm recording. Is there a difference between negative 1 over 2, 1 over negative 2, or a negative of 1 over 2? Is there any difference as far as the numerical value of those numbers?
No.
They're all the same. So when you are working with fractions, you are allowed to put the negative wherever it suits you, where it's ever convenient for you. Now, they generally do not like negatives in the denominator of a fraction. So if you get done at the end and you got a negative on the bottom, you need to move it to the top. But you actually can choose to move negatives wherever you like on fractions because it does not change the value. Okay, so you said you wanted something with more pizzazz. Well, okay, this is not that super pizzazz either. Oh, good time. Good point. Good time.